Today I've got a little Sanyo. It is a 26 inch. It's a DP 26671, although the model number is not important on this one. What is important on this one is that the main filter capacitor is ruptured, as well as the standby capacitor is bulged, and you can see some discoloration here. I'll zoom in on that. So starting with the AC input here, the first thing I notice is the metal oxide varistor right here is definitely damaged. I believe this was a result of a power surge. And let's move the camera up a little bit farther here. And we can take a look at the standby filter capacitor. Definitely got a bulge on the top of it, as well as the main filter capacitor has completely popped. The set was brought in as being dead, and I don't doubt that a bit. Okay, just a couple things with my voltmeter on the continuity scale. I want to go ahead and check that I have continuity. I'm going to check the main fuse. It is definitely open, as I suspected it would be. A couple other things. Let me move the board down here where you can actually see it. This right here is a pico fuse, is what they call it. This one happens to be a 7 amp. Don't know if you can read that on the camera, but it's labeled as 7 amp, 250 volt right here. That's good. That tells me quite a bit. That tells me that most likely the MOSFETs for the main power control are good, I should say. The other thing I want to check is this low value resistor. This should be about 2 ohms. It's a 2.2 ohm resistor. It reads 2 ohms on the continuity scale, so I'm happy about that. Now this is the resistor is in series with this filter capacitor, and it actually feeds this standby power transformer. This is the controller IC for it. I suspect it's good as long as this resistor is good. Like I said, I do suspect that this IC is most likely good, as are these two MOSFETs. So I'm going to go ahead and talk about this metal oxide varistor, what it is. They come in different voltages, different ratings, different current ratings. This one obviously is going to be a very small one, and its job is to clamp AC voltages in excess of about 150 volts as they come in. Sometimes they work really good, sometimes they don't. I'd have to say this one is in the don't category. Typically you can get them, like I said, voltage ratings anywhere from 130. They make lower voltage rating ones. I've seen them at 24 volts for like a sprinkler controller may have a 24 volt metal oxide varistor in it. I've seen them up into the 500 volt range for more industrial equipment. So I'm going to look around, see if I can find me a new metal oxide varistor, a new 7 amp AC input fuse, actually 6.3 on this one, and put them in the set, and let's see what happens. Okay, so I've got my ESR meter set up here, and I thought I would show you the test of the old capacitor on the ESR meter. It barely moves the needle whatsoever, as compared to what the new capacitor should test like. Should go right to 0. Anything less than that and it's defective. Even the small 47 microfarad capacitor, hard to hold, but almost barely moves the needle as I touch it to it. The replacement capacitor goes right to 0 ohms. And so the metal oxide varistor is all burned up. This is one you can actually check on an ohm meter to see if it's defective. So as I check this one on the ohm meter, it actually reads about 20 ohms. It's kind of moving around a little bit. The lowest I saw was 20 ohms. Definitely a problem. Shouldn't read anything. Here's the replacement metal oxide varistor. This one is rated at 130 volts AC, and it reads open as it should. So people have asked where to find an ESR meter. Just go to Google and just Google ESR meter, and what you can do is go down here for images. If you just want to find a schematic for one, here's one. It's from geocities.ws, and this I believe is the exact schematic I have in my ESR meter. Works very nicely. It's just a couple of ICs, very easy to construct. I don't think it gives you the part number on the ICs right here, but if you dive a little deeper into their website, you can find it from there. Next, I'm going to clean the circuit board. I want to get rid of the charcoal that's all over it here, or as much of it as I possibly can. And I'm not going to clean it in any way special. I'm just going to use my brush with my acetone, just as I use to clean the flux off the circuit boards. It does a quite fine job for cleaning items like this. Acetone does eat up plastic, but there's such a small amount of it that's actually affected by the acetone that I'm not even going to worry about it on this board. So that got it much nicer and cleaner, looks better to say the least. I just wanted to mention there have been cases where I've had customers spill things like soda on the circuit boards, and I've had to actually take some of the components off and wash the circuit boards in my dishwasher. Yeah, the same dishwasher in my video. Just make sure you dry the board really good. I usually I set them in my oven for about 30 to 45 minutes at about 160 degrees. Most of the water's evaporated off there at that time, but one thing I always do before I wash anything is I always remove the switching transformers, because the water can get in between the layers of the transformer and cause definite damage at that point. So I'm going to go ahead and put these parts back in the board, and we'll see if this set is a winner. Okay, so I got my board back in the set. It's all hooked up and plugged in. Hit the power button. We'll see what we get here. I see the backlight come on. That's a good sign. Everything should be working. Alright, so here's my set all up and running. Everything's looking good on it. So hopefully this will keep a couple more of these out of the landfill, out of the recycle box. Once again, appreciate your views, your comments, your suggestions. Of course, like always, I can't answer every single one, but I will try to answer as many as I possibly can. Thanks for your support. Remember, NorCal715 on Twitter. Everybody have a great day. Bye-bye.